Alright, Inspection Maintenance of Propulsion Dynamic Brake Systems Course 203 Preview Only Participation Guide Railcar Training Assortment. And this is the Course 203 of Inspection Maintenance of Propulsion Dynamic Braking System Table of Contents, Page Intentional Effect, I Use Participation Guide. Module 1, General Inspection Maintenance Overview, Preparing Inspection Maintenance Schedule, Summary. Module 2, AC Propulsion Overview, Master Control Blower, Propulsion Container, Switching, Filtering, Dynamic Braking, Power Inversion, AC Traction Motors, and Summary. Module 3, DC Propulsion Overview, Master Control, Propulsion Container, Blower, Switching, Filtering, Train Control, Dynamic Braking, DC Motor, Traction Motors, and Summary. And this is by the Transportation Learning Center. 203 Inspection Maintenance Propulsion Dynamic Braking System Case Studies, Learning Applications 1, 1B, 2A, 2B, 3, 2C, 3A, 3B, 3A, 3B, 3C, 3D, 3E. Module 1, General Inspection Maintenance Overview, Maintenance Schedule, PM Sheets, Keeping Records, and Summary. Our purpose of the objective, the purpose of this valve, the provide participant with an overview of the principle of the maintenance working on the railway vehicle propulsion. Use the completion mile of the participation should be able to complete the following object with the accuracy of 75% or greater. Emergency agency schedule. Explain agency schedule and inspection maintenance for the railcar propulsion dynamic braking system. Demonstrate ability to read electrical schematic. Railcar propulsion system dynamic braking system. Demonstrate knowledge of three-phase motor. Demonstrate the knowledge of capacitor charge. Demonstrate knowledge of electrical discharge. Demonstrate purpose of the thermal compound. Demonstrate knowledge of the pulse of the modulation. Key terms: preventive maintenance, PM sheets, periodic inspection sheets, PI sheet, portable test equipment, PTE, and line receptacle unit. Line receptacle unit. A line receptacle unit is a component of the rail vehicle that's designed to replace quickly by the maintainer. Sometimes these are called modules or designed with the operation equipment manual so that they can easily be removed and replaced with the other similar part. Depending on the configuration, operation, equipment maintenance design, some of the line replaceable units are located in the propulsion logic unit and high voltage assembly. For example, the CTA 5000 series cars or line reactors separate line replaceable units shown in figure 1.1. Shows the line receptacle unit, propulsion control, ventilation, plenum, traction blower, propulsion converter unit online, outlet, dot work, ventilation, plenum, traction motor blower number 2N. Diagnostic base maintenance. Diagnostic base maintenance is facility with a review of the propulsion logic system. Recall of the course 103 with the propulsion logic referred to the communication platform, managed with the control of the flow of the information both of the board of the railway vehicle between the vehicle and the ground. Propulsion logic system is housed with the propulsion control unit, which some of the technicians refer to as the brain of the train propulsion system. Depending on the operation, equipment and maintenance manual, the design of the propulsion control unit are housed and electrical enclosures located under the car locker inside of the vehicle or in other locations on the rail car of the project. Propulsion logic system allows the efficient, reliable train operation. Car monitoring unit allows for computerized base diagnostic base maintenance. Basic function of the propulsion logic system are therefore execute, monitor, protect, enunciate, and communicate. Propulsion logic systems relate with the nomenclature vary across the vehicle type, manufacturer, rail transportation agency, also vary location of the rail vehicle. Your propulsion control unit is designed in some kind of a computer-based interface that through the rail vehicle, the technician diagnose, test the report fault for the operation propulsion system. The exact design, configuration, software diagnostic capabilities vary for the operation equipment manual, especially diagnostic base maintenance allow over the rail car technician to connect with the portable test equipment such as the notebook with the car monitoring unit gains data of the propulsion subsystem in order for it to happen. There must be a software with the interpretate subsystem status and reports functionality for the technician as well with the communication link between the portable test equipment and the car monitoring unit. Diagnostic software allow the rail tower technician check with the staff of the propulsion system isolate particular fault, but typically includes the ability to download snapshot data propulsion system at the time of the inspection. Figure 1-2 schematic review representation of the propulsion diagnostic system. Use the Denver RTD, other Siemens of 0700 rail vehicle systematic design diagnostic system type of the rail car SIBAS 32. This is preview only. Show the operator with the control surface interface control and then COM IOU and power supply system bus drive computer converter control actual drive drive the driver face IO process interface AD interface output stage vehicle interface communication interface. COM stands for serial interface CIP signal processor AD analog digital IO input and output. Railcar technicians expect with the check with the reports for the propulsion diagnostic system as part of the standard inspection maintenance procedure. The participation should review with the training and other agencies specifically the diagnostic system. Alright, this shows Model 1 shows general inspection maintenance P2550 preventive maintenance sheet. That's preview only. And then it showed another previous maintenance sheet. Learning objectives, 1B, Module 2, Overview, Propulsion, Logic, Propulsion, Container, Ventilation, Switching, Filtering, Dynamic Braking, Power Inversion, Motors, and Summary. The purpose of the module will provide the participant with the framework of the steps involved with inspecting, maintenance, testing with the major component of the AC propulsion system of the rail cars and used in the major U.S. transportation agency. Following completion module, the participant should be able to complete with the objective of the accuracy of 75% or greater. Inspect with maintain inverter, inspect maintain master control, inspect replace IGBTs, inspect maintenance propulsion blower, inspect replace filter capacitor, inspect clean choke line inductor, inspect maintenance high speed circuit breaker, inspect replace ground fault sensor, inspect maintenance contactor arc chutes, check resistant multimeter, clean the lube knife switch, inspect maintain DC link, inspect clean lubricating traction motor blower, inspect maintenance speed sensor attack sensors, inspect maintain speed sensor cable, check contacts, inspect clean braking resistors, inspect braking choppers. Key terms: arc chute, blowout coil, car mounting unit, contacts, line breaker, shunt, master control, propulsion, logic, traction, container, trip coil. 2-4 blower propulsion sample. The propulsion blower provided with the cooling air with the propulsion container that air is drawn in through the screen of the grills to the side of the vehicle, passed over the cooling fins of the IGBT module of the line. Reactive of the cooling air isn't necessary to maintain with the temperature of the IGBTs. The rise in temperature outside of the IGBT limit will result in the reduced performance and will directly affect the propulsion system. If there's a failure with the propulsion motor with the train operating with the resulting increase of the temperature, propulsion system will increase the traction control unit to a signal restricted speed mode of the vehicle. Your blower inspection maintenance, check with the voltage blower, check with the blower housing of the security of the operation. Equipment maintenance manual tighten, check for the dirt buildup of the blower, check clearance between the blower housing, examine the bearing failure. Check motor shaft at the end if it is not bent, and listen to excessive bearing noise, check and clear inlet exhaust of screens, ducts, filters with power, remove, check wiring and meter. High-speed circuit breaker. The newer rail vehicles on high-speed circuit breakers to protect them from disastrous situation. High-speed circuit breakers have two major functions: provide short-circuit protection for the propulsion system, contact with the power source for the catenary third rail voltage, main voltage propulsion system, disconnect with the power source with the vaults. To make off with the excessive line switch only when to occur. At best, the faulty high-speed circuit breaker unit can cause the train to stand still. At worst, faulty unit of the blow up units of the rail vehicle propulsion infrastructure personally lead to human casualties. Proper testing, regular inspection, accurate maintenance of the high-speed control circuit breaker. Therefore, critical function of railroad maintenance due to the assistance of the instructor on the additional hand lessons life. List your agency with the assistance of the instructor addition hands-on lessons. List your agency requirements, inspection, maintenance of high-speed circuit breaker next to general recommendations in the following table. Figure 2 flash of the side view high-speed circuit breaker courtesy of PATCO. High-speed circuit breaker inspection and maintenance. Adjust the high-speed circuit breaker. Check with inform to remove the excessive dust debris. Inspect with clean arc chute. Ensure all components with the secure with the serviceable. Check all small wire and cable insulation overheating damage. Inspect high-speed circuit breaker contactors. If indicating overall high-speed circuit breaker, file with the recommendation of operation equipment maintenance and agency. Dynamic braking. During dynamic braking, when the traction motors act with the generators converting energy with the rotating wheel with the electrical current with the conversion of kinetic energy electrical show with the rail car, the module section dedicated with the inspection maintenance for the AC motors, section focused with the two major components of the braking resistor, brake chopper, the braking resistor, dissipates dynamic braking energy, discharge of the filter capacitor with the following list of the separate with the steps for the inspection, cleaning, and the testing of the braking resistors. General recommendations: make sure the component of the braking resistor inspection. Make sure the components secure with the brake resistor, set for the cable, the mechanical part, shield with the knot loose for the damage, repair, replay with the necessary. Make sure screws fasten the brake resistor of the car, underframe and secure with the torque mark with the Israel present. If not, torque with the operational equipment maintenance manual recommendations and apply with the torque seal recommended. Prefer to make it ensure the suitable component. Check for the crack of the broken mounting insulator, even if the crack is suspected in the insulator ceramic spacer. For example, to perform a Megger test, check for the braking resistor abnormal overheating, burnt open, distorted sagging elements. Make sure the wiring, insulation, and damage. Check no cracks or abrasion damage are present. Inspect resistor assembly, grill work. Remove any objects, paper, plastic bags, etc. that may restrict the cooling airflow. Make sure no excessive accumulation of the dirt and contaminant materials are. The following case study with the application of LED indicating system that indicate the condition of the brake chopper modules. Case 2 study, Denver Regional Transportation District configuration brake chopper model of the Regional Transportation District SD160 LRV manufactured Siemens. Brake chopper configuration. Each inverter with the brake chopper module with each of the brake chopper has 8 IGBTs, which are mounted with a 2-row for each module board. 4 IGBTs and each row of the connected pair with the brake chopper that has 4 terminal posts. LED indicate the condition of the IGBT phase module tester with the plugs directly with the brake chopper. The module's 15-pin test plug receptacle with the rail car technician test car. Should the individual IBTs, the test plug receptacles, LED test points, LEGs, brake chopper module courtesy Regional Transportation District of Denver. 2.7 power inversion. Practice should be recalled with the course 103, but the power inversion refers to the capability of the certain devices of the propulsion circuit that chain with a high-speed DC input voltage, AC voltage output, AC motor. 2 major components of the power inversion are propulsion logic control unit and propulsion inverter. Propulsion logic control unit, the propulsion control unit in the housing propulsion logic container. Propulsion logic control unit inspection maintenance. General recommendations: remove connection main power, verify all mounting supports, hardware is firmly fastened, inspect all connectors, wires, wears, corrosion, any other visible change. Inspect dirt and debris and if necessary clean with a non-deductive close. Case study 2.8 Chicago Transit Authority. Proceed with the inspect with the logical unit the component of the Chicago Transit Authority 5000 interior rapid transit car, numbered in parentheses in figure 2.9. Verify all mounting screws. 2. Firmly fasten with the VCUC unit, 1 MIO1 unit, and 6 MIO2 unit when the battery holder. 8. Verify ground strap. 3. With the screw fasten the ground screws. 4. On the VCUC, 1 MIO1 unit, 6 MIO unit 2 unit, 7 ground stove mounting plate. Make sure that the ground strap 3 is not abraded and corroded. 3. Verify battery holder securely fastened connectors for the battery holder. 8 and VC unit VCU C1 and the cable is not abraded but corroded. Ensure male and female multifunctional vehicle bus terminal plugs 5 are in fastened screw with the VCU C1 and MIO1 unit 6. Inspect all connector wires, wear, corrosion, and any other visible damage. Inspect dirt and debris, clean if necessary. Follow use the soft cloth white dust off of the unit related components connecting hardware. B. Verify air holes behind the unit face are obstructed. If necessary, soft brush remove the dust build up air holes between cooling vents of the unit. 2.8 AC traction motors. AC traction motor convert to the electrical engine produced the propulsion invert mechanical engine with the propel the train forward. The motors can also use as generator to convert kinetic energy with the train back's electrical energy slow the train B with the dynamic braking. General recommendation: air in and outlets clean. Inspect the debris with the damage spin sensor clean. Traction motor similarly inspect with external damage. Check with the external connection. Inspect sign with the condensation. Overall per operational equipment maintenance and agency recommendation procedure. Bearings relubricate, indicate, replace per operational equipment maintenance and agency recommended procedures. Case study 2-9, bombardment 5000 Series A and B car, Chicago Transportation Authority, inspection traction motor, 1 inspect speed sensor, 1 cable to design, for end cable for damage sign with the burning, overheating, replacing cables and or speed sensor if necessary, 2 inspect coupling flange, bolts, verify torque mark fastener, washer and mounting surface to clearly visible, all segments align, replace all any loose, missing, detach, damage hardware, inspect truck cable leads, damage sign with the burning, overheating, replace cables if necessary. 4 inspect traction motor mounting assembly with the motor mounted hardware, motor mounting bushing. 4 verify torque mark on each fastener, washer mounting surface that clearly visible, all segments are aligned, replace any loose missing hardware. 5 check air inlet duct. 5 for damage, replace if required, and shows preview only. It shows the picture of the traction motor. Module 3, overview, master control, propulsion container, ventilation switch, filtering, traction control, dynamic braking, motors, and summary. Alright, the purpose of this model will provide participant understanding the steps involved with inspecting, maintaining, testing major component with a DC propulsion system on a rail car by the major U.S. transportation agency. Following completion of the module, participation should be able to complete with the objective with the accuracy of 75% greater with the maintain with the chopper, inspect and maintain cam control, inspect and maintain master control, inspect, maintain propulsion logic control unit, inspect, maintain ventilation system, inspect, maintain high-speed circuit breaker, inspect, maintain contact arc chutes, inspect, maintain resistant banks, inspect, maintain knife switch, inspect, maintain overcurrent protection. Key terms: main chopper circuit and brake chopper circuit. 3-1 overview. A DC propulsion system with the use of the cam control of the chopper circuit with supply power to the DC control current traction motor, thereby providing means that the accelerator of the rail car provide a dynamic braking complex system with many components. This course has been organized with a DC propulsion system with the 4 functional areas: switching, filtering, traction control, dynamic braking, and motors. With each of the 4 areas of the module described as standing with the procedures for the main components as well, with some of the subcomponents of the procedure may not specify with the rail cars as participant expected to inspect, maintain rail transportation agency. The course should be supplement further training either with the classroom on-job rail vehicles, specifically participant agent. So you show the switching, and it shows master control of 2 switches as the high-speed circuit breaker and line contactor with a resistor as a pre-charge and pre-contactor energy, and that's on the positive side. But then from the switching, it goes into filtering, which gives the line reactor, and then it goes in filter capacity with it runs to the negative, and then master control from switching goes to dynamic trigger and traction control, braking, propulsion control logic, and then the line reactor with the positive side goes to accumulating braking resistors, and there's 3 of those, and it goes to cam controller, chopper circuit, into the reverser, and motor DC traction motors 1 and 2. Course help participation examine the maintenance of the machine of the model with their approach to the inspected maintenance major component of the rail vehicle propulsion in order to incorporate with the variation rail car propulsion system module. You have the 3-part approach with the licensing recommended practice for the inspection maintenance and overview of the propulsion component with a given in general layout shown in figure 3.1 is the guide showing the general recommendation inspection maintenance of the component base side of the participant and can note with the any agency specified inspection maintenance requirements of the component. Case data with the assortment rail agency listing on the step of the agency file with the inspection maintenance for that component. 3.2 master control. During revenue shift of the master control is operated with the train operator in the cab. The master control will require the drive and the brake rate for the manipulation of the P signal value with the propulsion logic unit, and then show the master control manufacturer's shell in the butt. Master control inspection maintenance. Remove contact connection to the main power and vacuum clean surface of the component. Test and handle mechanical interlocks. Visually inspect the movement step of the verifying contact movement and connection to the PTE. Portable test equipment and safety interface. Verify signal received with the logic control unit. Clean contact sheet with a non-corrosive cleaner, non-conductive cloth. Tighten connections needed. Inspect connection harness. Replace master control when all maintenance exhausted and unit fit continues to fail rare. Our case study 3.2 Niagara Front Transportation Authority seals all air leaks in the inlet and outlet side of the blower to prevent entrance in the dirt or lost air. Change filter for the per operation equipment maintenance recommendation. Agency guideline. Change brush for the per operation equipment maintenance agency recommendation. Check for the damage of the wheel with the fan. Check fan with the wheel balance vibration notice, and check with the bearing drive alignment, shaftness, straightness, wheel loose on the shaft, loose or worn bearings, looser mounting bolts, motor out of balance, worn or corroded wheel, accumulation material on the wheel, Shift of the wheel for wear on the fan blades. Replace with the rebuild per agency recommendation. And then it goes into line input, propulsion container, contained with the line contactor, pre-charging circuit with the line reactor, pre-charging circuit functioning slowly with a DC link capacitor up to required voltage pre-charge resistor together with the DC link capacitor with the line reactor from the line filter. Where your line contactor acts as a main high voltage connection for the propulsion container, the task activate, deactivate the charger with the line contactor app open with the power flow for the pre-charging contactor, pre-charging resistor, charge of the uncharged flow link capacitor, and does operate under load in order to shut the off supply voltage, both nominal operation as well as some of the emergency situation, and shove the line contactor with the arc chute courtesy of SDMMTS. Line contactor inspection, general recommendation, visually inspect line contactor, check contact tips and arc chute. Case study 3-4, Port Authority Transit Corporation. Inspecting the line contactor. Unlock, open the circuit breaker handle behind the operator cab, turn off the propulsion brake electronic circuit breaker, open and uncover the high voltage cubicles, remove the arc chute with the visually, check the condition of the contact. If the contacts are worn, to limit the replay of the contacts of the operational equipment maintenance recommendation, reinstall the arc chute, reinstall the high voltage cubicle. 8. The field module testing lists 4 steps on the photo below with circle and label the following A, B, and C. The disconnect cable of terminal F11 jumper for the positive of the battery lead F11 and load resistor connection from terminal F112. Alright, during dynamic braking, the traction motor generates converting the energy, rotating the wheel with electronic current conversion, kinetic energy, electronic shift of the rail car. The module has a section dedicated to the inspection maintenance AC motor. In this section, focus for the 2 major components of the brake resistor, brake choppers. Brake resistors dissipate with the dynamic braking energy, discharge of the filter capacitor, and the following list of separate steps of the inspection, cleaning, testing, braking resistor. General recommendation, make sure the components securing the brake resist for the touch for the cables and mechanical parts and shield are not loose for the damage, replace for the repair or replace is necessary. Make sure the screws fasten the braking and resistor car underframe and secure. Torque markers forever than not with the torque of the operational quota maintenance recommendation. Apply with the torque seal as required. Perform Medicare testing and suitability of the component. Check cracked or broken mounting in insulator, even if the crack is suspected in the insulator ceramic spacer. For the example, to perform a mega test. Check the braking resistor abnormal, overheating, burn, or over distorted sagging elements. Make sure the wiring, insulation undamaged, no cracks or abrasion damage is present. Inspect the resistor assembly grill work. Remove any of the objects and paper, plastic bags, etc. that mirror shit cooling airflow. Make sure that no excessive accumulation of the dirt and contamination materials are present. Steam clean if necessary. Alright, case study 3-7 Denver Regional Transportation District. Steps in due for the DC motor brush. Notice surface of the communicator should be evenly colored and smooth and clean. Inspect condition of the copper segment, the edge of the necessary for the deburr with the copper brush, indicating between the copper segments less than 0.8 of millimeter deep for re-scrape. If an insulating slush of less than 0.8 of millimeter deep, re-scrape brake edges with a deburring tool. Flash over tracks indicated pour brush contact. Flash over is present. Communicator must be ground and skimmed. And it shows 90 degrees, 1 millimeter, 2 millimeters, 1.25 miles, 8 millimeters. And ask some questions and then alright, your reverse of the reverser chain of the direction, rotate the traction motor, reversing the direction of the current through the motor fields. General rail car technicians expect with the tap of the reverser operation during the complete check of the other motorized driven direction switches. Reversers may require inspection maintenance procedures such as the lubrication if an operating equipment maintenance, lubricant, and show the contact fingers, reversing drum. General recommendation, visually inspect the reverse contactors for wear, clean, indicated lubricate reverse drum following the operation equipment agency recommendation. Case study 3-8 Bay Area rapid transport step lubricating reverse open 1 the magnetic valve to move the drum. 2 acid brush apply a light coat of lubricant to the drum. Use only operation equipment maintenance specific recommendation for the acid brush and lubricant. And this was a preview of Inspection Maintenance Propulsion Dynamic Braking System Course 203 Transit Training which is you got to pay for, which this is just a sample. All right, thank you. Bye bye.